Let's understand the formula for the linear regression coefficients. That is the formula for both alpha and the beta. Now, if you have simple linear regression, that is, you have just one x variable in your data, you will be able to compute the values of alpha and beta using this formula. Now, let's suppose you have the data where your x is your area and y is your price. Amongst various different candidates that is possible for the line of best fit, say, let's imagine that the linear regression determined a line like this. All right. For this to be the line of best fit, the sum of residuals of all these points should be the least, should be the minimum. What do I mean by residual? For example, for this particular data point of this line, this is not exactly falling on this line, isn't it? There's a certain distance between the actual value versus what is predicted by the linear regression for this particular value of x. When x is this much, the linear regression is predicting your y, which is the price, to be this much, isn't it? But the actual value of y is lying somewhere over here. Now, the vertical distance, the distance along the y-axis between the line and the actual value, this is called as the residual. Note that this is not the shortest distance. This is not the shortest vertical distance. This is the shortest distance, whereas the residual is the distance measured along the y-axis. Likewise, it computes the residual between all these points that we have in the data, right? All these points, you compute the residuals. The sum of squares of residuals of all these points will be the minimum for the line of best fit. And why are we looking at the sum of squares? Because we don't want the residuals to cancel out. For example, this could be a positive residual. This could be a positive residual, whereas this is a negative residual. If you just take a sum of squares, the positive and the negative value would cancel out, and that might not yield the best or the accurate line of best fit. Whereas we want the sum of squares to be at a minimum level. So the equation looks something like this: y equals to alpha plus beta x plus e. This is nothing but the residuals. The alpha is nothing but the intercept, and beta is nothing but, say, you measure 1 unit along the x-axis, you measure 1 unit along the x-axis, and this is theta. The slope beta is nothing but tan theta when your x is 1 unit. So this is equal to b. This will be the value of your beta. Right? When x is 1 unit, this vertical distance is nothing but the value of your beta. Now let's look at the actual formula. The formula is the value of beta, the slope tan theta, which is nothing but beta, is nothing but the covariance of x and y. So you have your data, right? In your data, you have your x and y. The covariance between your x and the y divided by the variance of x. This works out to, for all the points in the data, xi minus x bar. X bar is nothing but the mean. Yi minus y bar, whole thing divided by n. Likewise, divided by, for all the points I equal to 1 to n, xi minus x bar whole square divided by this n, and this n will cancel out. So this whole thing is the value of your beta, the formula of your beta. Right? Once this is your b or beta, right? This is computed. Once beta is computed, alpha is nothing but y dash minus b into x dash. B is nothing but your beta. So alpha is nothing but y dash minus beta into x dash, where y dash and x dash, these are the mean value of the respective columns, the mean of the x column and your y column. That is nothing but your y dash and your x dash.